Hey everybody, this is a video about parallel lines cut by a transversal. This is a North Carolina 8th grade math standard and it involves several skills. So question number 4 on this worksheet is a good example of what a student might see on an EOG if they were taking that, because there are a lot of skills involved. They have to know the relationships between the angles. They have to be able to set up equations. They have to be able to solve equations. They have to be able to do many steps and do every step correctly. So even though they might not do this on a job someday, the theory behind this is being able to see patterns, solve problems, go through many steps to reach a solution, those types of things that they would have to do on a job someday. So I want to talk about how we would do some of this stuff. So we first begin with the understanding that the angle relationships I'm about to talk about exist if I have parallel lines. If these two lines are not parallel, then the angle relationships I'm about to show you would not work in the real world. But they are true in the real world. You could do actual measurements and prove that, and we like to do that with students and prove that these are true relationships if these two lines are parallel. And then the transversal is the line that is drawn through parallel lines. So the direction might change. Here are two parallel lines. That's the transversal drawn through them. So as you see, they change the direction around. Here's two parallel lines. There's the transversal. Here's two parallel lines. There's a transversal. So the skill there is being able to identify and look for patterns and look at relationships between the angles. Let's talk about those relationships. So here I have laid this out so that someone could come back and freeze this part of the video and look at all of this stuff here to help them answer the questions on that worksheet or other work like it. So again, you could freeze this part and get some help to understand which angles are equal to each other and which angles would add up to 180 degrees. Because if you can figure that out and know that, then you can set up your equations to get your answers. So one of the first relationships we look at is vertical angles. So that's when I have any two angles that are across from each other. So if I look at angle 1 and angle 4 here, I have two lines that intersect, and those two angles that are formed across from each other, those are vertical angles, and they're equal to each other. So in the real world, we could measure these angles and prove that angle 1 and angle 4 are equal to each other. And then, by the same token, I could also prove that angle 2 and angle 3, those two angles are equal to each other. So we call those vertical angles. And over here, I have a reference for you. 2 would be equal to 3. 1 is equal to 4. Of course, 5 and 8 would be equal to each other. And 6 and 7 would be equal to each other. So how that can help us is then if I have a problem that says angle 1 is 3x and angle 4 is 9. And for some reason, the person wants to know what x is, right? If it was set up like this, if you had to solve for x, well, all you really need to understand here is the relationship between angles 1 and 4. 1 and 4 are the same. They're equal to each other. So that means 3x is equal to 9. That's how you would set up your equation. If two things are equal to each other, then just set these two expressions equal to each other. And if 3x is the same thing as 9, then the student would solve and obviously know that x is equal to 3. So anytime you're given two expressions and the two things happen to be vertical angles, then just set them equal to each other. Now, let's talk about alternate exterior and alternate interior angles. So for alternate, we teach the students that that just means opposite, and it's talking about angles that are on opposite sides of the transversal, and we'll be able to see that better in the context of whether they're exterior or interior, so you know outside and inside. So let's talk about the interior angles. So interior means anything, any angle, I should say, these angles that are on the inside here when I've got these two parallel lines. So all of this is interior. And so angles 1 and 2 are exterior. Angles 7 and 8 are exterior. So again, if these two lines are parallel, then alternate interior angles, so that means this and this, these two things are equal to each other because they're on the inside of the parallel lines, but they're on the opposite side of that transversal right here. So 3 is equal to 6, and as you can already see then, 5 is equal to 4 because they're on opposite sides of the transversal and they're on the inside of the parallel lines. These are alternate interior. So again, if you were told that this was 3x and you were told that this was 9, excuse the bad writing, these two things are equal to each other. So you could just set 3x is equal to 9 and have that relationship there. So I'm going to take away these. So now alternate exterior, our exterior angles here are 1 and 2, 7 and 8. So by the same definition, 1 and 8 are on opposite sides of this transversal. So 1 and 8 are equal to each other. I have that over here. And 2 and 7 are equal. 2 and 7 are equal to each other because they're on the outside of the parallel lines and they're on the opposite sides of the transversal. So it's pretty cool if you have two lines anywhere out in the world that are truly parallel and you draw this line through there, you can prove these relationships, that these exist. Another set of angles that are equal are corresponding angles. So I have this set here. So the easiest way I can show it visually is this and this are corresponding. Everybody see that? See how those two things are corresponding to each other? We could prove it other ways, but that would take longer than I want this video to be. So I'm just asking you to trust me here. 4 and 8 are corresponding angles, so they are equal to each other. And I have those sets there. Again, not trying to make this too long. This frame will be here. Now, all of these are angles or sets of angles that would be equal to each other. Supplementary is different because supplementary angles are not equal to each other unless both of them are right angles, unless it's 90 and 90 equals 180. Because supplementary, by definition, means that the two angles or the set of angles add up to 180 degrees, which is half of a circle. So I ask my students to visualize a 180, right? The kids know that a 360 is a full circle, so a 180 is a half circle. So anywhere they can see a half circle, that is a 180. So there's a 180, there's a 180. So 1 plus 2 is 180. 3 plus 4 is 180. But then I ask them to look at it this way. 1 and 3, that's a half circle. These two angles, 1 and 3, would equal 180. If I get one more color, 2 and 4, that's a half circle. So 2 and 4 add up to 180 degrees. So there's all kinds of options here, and I have that set here. And again, the same thing is true down here. If I'm looking across a straight line, these two angles add up to 180, like this and this. So that's going to come in handy on the worksheet as well. So I wanted you to have that frame there. We'll leave that and go back to this now. So now let's look at this worksheet. So here we are told that this angle is 14x minus 13 and this angle is 8x minus 5. So as you can see, these two angles are inside of the parallel lines, but they're on opposite sides of that transversal. So these are alternate interior. They're equal to each other. And so the students set this up properly. So 14x minus 13 is the same thing as equals 8x plus 5. They solve for x and get x equals 3, and that's an answer at the bottom of their sheet. That's an option. In this case, these two angles are corresponding angles, so they are equal to each other. So the student just said 9x plus 1 is the same thing as 11x minus 23, and they can solve for x, and they get x is 12. Now something happens here. The student said that this angle is equal to this angle and set it equal. They solved for x, but it's not an answer choice. And at that point, the student says, okay, I must not have set something up right. And so let's take a second look at this, okay? These two angles on the inside here are actually supplementary angles. These two things add up to 180. So again, without going through all the different parts to prove that, this plus this add up to 180. So that means instead of saying that these two things are equal, we should say 3x plus 5 plus 7x minus 15 equals 180. And so students, at that point, when you take all of this together and say that it equals 180, then you combine like terms. You'll get 10x minus 10. When you combine 3x and 7x, you'll get 10x. 5 minus 15 is minus 10. All of that is equal to 180, and you'll solve for x, and you'll get a different number from 5, which will be one of your answer choices that would be on the bottom of that worksheet. So here we add a step. Now we're getting more complicated. So I'm not going to just give the answers in this video, but I want to help you know what to do. So first of all, let's look at these. Both of these expressions have the variable x, but I'm told I got to find the value of y. So I already know this is going to be a multi-step problem. So I start with what I know. What I know is that these two angles add up to 180, but I have an issue. I can't add them up and say equals 180. I'm not going to get very far because I have an x and a y. So it's not going to get me very far. What is going to get me farther to start with is if I use these two expressions because they both have the variable x. So they happen to be alternate exterior angles. If you notice, they're on the outside of the parallel lines. They're on opposite sides of the transversal. So 8x minus 61 equals 6x minus 13. So you're going to set these two things equal to each other, solve for x. Okay? You're not done. When you get x, let's say x was 100. I don't know what x is. If x was 100, you would put it right back there. I need to know what this angle is. I need to know what this angle is right here. So once I've solved for x, put x right there. 8 times whatever the number is, then subtract 61, and you're going to get this number. Again, I don't know what it is, but let's say it was 50. Doesn't look like 50, but let's say this, you get 50 here. Well, 50 plus this adds up to 180 because these two things are supplementary. These two angles add up to 180 degrees. So when you get this angle, just say that angle, that whatever the number is, plus 3y, looks like 3y plus 1 equals 180. So I'm going to say that again. Whatever number you get here, that number plus 3y plus 1 equals 180. Well, then you solve for y, and you have y. Okay, I'm going to look at number 5 and number 6 now. In number 5, what I can do here is say that these two things add up to 180 degrees. So 4x plus 23 plus 9x minus 38 equals 180 degrees. So students, you combine your like terms here, combine these like terms, equals 180. You're going to solve for x, and you're going to get x. So again, let's say you put x right here, and you get that this is 50 degrees. Again, I'm not saying it's 50 degrees, but if it were 50 degrees, then you know that that's 50 degrees because this angle and this angle, these two things are alternate interior angles. They're equal to each other. So whatever number you get here, it is equal to 21y minus 1. And then you're able to solve for y. Finally, let's look at number 6. These two angles are vertical angles, so they are equal to each other. So 9x plus 42 is equal to 15x. So this is the same thing as this. I solve, I get my x. And I can put my x in for either of these angles and get the angle there. So in a shortened version of this, what I would then understand is that this angle plus this angle add up to 180. So whatever number you have here, this plus 4y minus 13 equals 180. And then you're solving for y. I hope this helps. I didn't want this one to be too long, but if I need to, I can do a follow-up video where I actually work out some of these and you can see me work them out. Thank you.